So basically what you do, if you've got, like whatever your free body diagram is, you just look at your forces and you just decide to put your, what you try to do is put your x-axis along, or one of your axes along the terms of motion. So like the ground's like this, so you know your motion's gonna be something like that. And then you also try to get it perpendicular, like as many forces as possible perpendicular to the forces. So like straight on with these forces. So that one makes the most sense. If you turned it, you put it this way, then you would have to break it down to figure out how far it was moving, and then you have to break down all three of these vectors.
Gotcha. This was just use the component from form of Newton's second law to write an expression of the x component of the net force. Sum of Fx.
So what did we say? We got force of gravity, normal force, some pushing force,
Yeah.
and a kinetic friction force.
I mean, like an angle. Like theta.
And then, does it show which one is the angle now? Scroll back up and see. Oh, okay. I guess we'll just call this theta right here. So how do you understand what it's saying? Like, write an equation for the forces in x?
Just writing an equation. You don't have to solve it or.
Right, we don't have to solve it yet, but what would the equation be for the forces in x, like the net force in x?
For x.
This is when you do like this kind of thing, the sum of all the forces in x.
Okay.
And that's equal to, you just take anything that's in the x direction and you add it up. So what forces are in the x in this?
Kinetic force.
So you've got a friction force.
Friction force.
Will that be positive or negative?
Negative.
Okay. What else?
X direction. The pushing force. It's a negative. Or is it? Oh no, it's X. Okay, yeah, positive.
Yeah. But is it the entire force here?
No.
So what do you do with that to get it just in the x direction?
So the cosine of the angle.
Yeah. You can multiply by cosine of theta. So that would be your equation in x. And I'm not sure, it tells you what variables to use. Okay, so this is a capital F. Okay.
Just sum of all the variables. So it's negative F. F K.
Yeah, I think that you have to use that. You like click on that box and it gives you the other option. It gives you the option to do subscripts and stuff.
There.
Yeah.
Plus FT.
asking for sum of y now.
Second law of the right expression for y component, yeah.
Yeah. So what would this one be?
F, the sum of f of x equals Fn force plus, or like, minus Fg. And minus the pushing force sine theta. And FG. P.
Oh, wait a minute. So this is positive, all right?
Oh,
Variables are case sensitive. So your G and your N have to be capitalized.
okay. Alright, seems kind of picky, huh?
Yeah. It didn't take any points off you for that though.
Okay, what the magnitude? What's the fastest way to find the magnitude? What is the magnitude of the acceleration?
So you've got
Area of the chair.
you got your equations here. So the sum of forces in x
Chair.
equals negative force of friction plus the force of the pushing times the cosine of theta. And that's all equal to something else. This is, you have this equation. So F equals ma. So this ends up being the net force in x. So it's equal to the mass times the acceleration in x.
Okay.
And the same thing with this one. You got the sum of forces in y equals Fn minus Fg minus minus Fp sine of theta. And that equals m times the acceleration of the y. So the fastest way to find acceleration is just to divide by this.
Okay.
And then, what do you know about the acceleration in y?
Zero.
Right, because it's not moving up and down at all.
Right.
So this is all equal to 0. So that's why it's saying you can solve for Fn now.
Okay.
So what would the acceleration in x be in terms of these?
In terms of those,
So it's assuming that you know the pushing force, the force of gravity, and the angle, I think. What does it say you can use? Express your answers in meters per second squared. Oh. So what does it give you? Go all the way to the top, see what it says. Okay, so
so
FP,
it's 152 newtons.
and it's directed at what?
35 degrees.
Below the x-axis? Or below the horizontal?
Yeah.
So that's our angle theta. Okay, and then how much does the chair weigh?
45 kilograms.
So that's the mass of the chair. It's 35 kilograms?
45.
45 kilograms. Okay. So we know.
The friction is 89.8.
Oh, and then the force of friction. Okay. So we want to solve for the acceleration in x and the normal force. So we said that we have these two equations.
Yeah.
So how are we going to solve for acceleration in x?
So do negative 89.8 plus 152 times cosine of 35 over the mass 45.
And the way you can check this, so all the top pieces are in newtons, and then the mass is in kilograms. And a newton, 1 newton is equal to 1 kilogram times meters squared, meters per second squared. So newtons are in terms of kilogram times meters per second squared. So if you have newtons on the top and kilograms on the bottom, you just cancel out and your units become meters per second squared. So.
Oh, so anytime we have newtons and kilograms?
Yeah. So that's why these are in newtons, and then this is in kilograms, but you're gonna end up with units of meters per second squared.
Okay.
So, and it's just because of this. You can see force equals mass times acceleration. So the units of mass are 1 kilogram. Units of acceleration are meters per second squared. So, force equals mass times acceleration. That's how it works.
We just found this, the equation just from finding the x and the y.
Right.
The y, this form, whatever. How'd your test go, by the way?
Not a dynamics one?
Yeah.
Good. Didn't take too long, and we got a good score, so
That's good.
that's what I was shooting for. So we started with the free body diagram. We just summed our forces in x. We know that that net force will be equal to our mass times acceleration, so then we just divide by our mass to equal this.
3.77136.
Okay. So 0.7 meters per second squared.
Yeah.
That makes sense. You push it for a couple of seconds, you're up to 2 meters per second or something like that. It's a reasonable answer. Is that right?
Should I put the whole thing in, or?
Um,
I would probably remember it. Separate terms.
oh, yeah, so there's, what is the acceleration and then what is the magnitude of the normal force? So this is our acceleration, so just leave that. And then we've got to solve for the normal force too.
Okay.
So you put this in and then a comma and then your normal force.
Okay. My normal force is, what is it? Find it.
So the normal force came from when we were summing our forces in y. So it's right here.
Right.
And we know our pushing force, we know our mass, so we can find our force of gravity. We know this is equal to 0.
Okay.
So how do we solve for Fn?
So, force of gravity is just the mass.
Yeah, so force of gravity is, it's the same as, it's your mass times acceleration. So you have mass and then the acceleration is gravity. So it's mg. So this would be 45 times 9.8.
Okay.
So that's something that you just have to watch out for, because mass isn't your force of gravity. It's actually the mass times the magnitude of the acceleration of gravity.
Okay.
So you've got Fn equals Fg, which is 45 times 9.8.
Then you times it by the push, pushing force, or not times it, but minus, subtract it.
Well, you take this one, you add it to the other side, because negative on the side would be positive on the side. So then the same thing with this one. So you actually add it. So 152 sine of 35. And that makes sense because what's happening is you've got gravity that's trying to push this chair through the floor. But then also when you're pushing on it, you're kind of pushing it down further into the floor. So that's this. So the full force has to cancel out both of these.
Okay.
Because you know that no matter how hard you try to push on that chair, you're not going to push it through the floor. So the harder you push, the harder the floor pushes back
Right.
to cancel out that force. So that would be your, it makes sense that you would add up your weight and how hard you're pushing down on it.